And here we go. So it says use your unit circle. You have your unit circle handy. Also, let me go just a little bit over on the side. On the side of the board, I put Pythagorean triples. And the Pythagorean triples that I put are the common if you do a squared plus b squared equals c squared, these ones are the most common ones that come up most often. Since each question has so much space, I'm going to have to scroll down every question. That means you need to stay with me on notes. Okay? The first question is just like what we did last Friday. Find all 6 trig ratios of 3 pi over 4. So you're like, where's 3 pi over 4? So you get your unit circle out. And I want to show it up on your screen. That's mine already. I was just showing it to you guys. Oh, it's under. So when it says 3 pi over 4, you look at your radians and you're like, where's 3 pi over 4? Where's 3 pi over 4? Oh, here it is. It's 135 degrees. So what I need to do is I need to draw. So I'm going to go 135 degrees. It's this direction, right? Counterclockwise. 135 degrees is here. 135 degrees. That's what 3 pi over 4 is. And then I need to just look and say, this is going to be my triangle. Obviously, from 90 to 135, that's 45. This triangle, this is how you draw your reference triangle. The x-axis has to be a part of the triangle. And to get to 180 from 135 is a 45 degree more, right? So then it's like, okay, well, what's my x and my y? What are my legs on the 45, 45, 90 unit circle triangle? I hope you're noticing that this is negative rad 2 over 2 on the x, right? Going left, so that means it's negative. On the y, it's positive rad 2 over 2, going up, yes? My radius is always a 1. So the 6 sine 3 pi over 4, cosine 3 pi over 4, tangent 3 pi over 4. And by the way, I'm wearing my Pi Day shirt today, even though Pi Day was yesterday. So, okay, sine. Remember this? Sorry, there's lots of things I want to tell you about. Opposite over hypotenuse. Rad 2 over 2 over 1. It's just rad 2 over 2. And sine is positive in quadrant 2, remember? Sine is positive in quadrant 2. Cosine, adjacent over hypotenuse. Adjacent, negative rad 2 over 2. Cosine in quadrant 2 is negative. Oh, negative answer. Tangent, y over x, remember? Y over x. Opposite over adjacent. Well, I have opposite, rad 2 over 2, over adjacent, negative rad 2 over 2. I have the same number on the numerator and the denominator. What does that mean? What's that value when you have the same thing in a fraction?
1.
1. And so it's a 1. Then it's positive divided by negative. -1. Good job. My matching reciprocal cosecant, secant, cotangent. You just reciprocal. 2 over rad 2, which we do rationalize the denominator, just becomes rad 2. That's cosecant. It's the reciprocal of sine. Secant is negative. The numerator is 2, the denominator is rad 2. However, I have to do reciprocal. I work it out. The answer is negative rad 2. Cotangent. What's the reciprocal of -1? -1. Still like freezing rain cold. Right. 66.2. All right, I'm going to example 8. I'm scrolling down. Okay, now I'm giving you an angle in radians and I'm giving you an angle in degrees. Example 8. I'm giving you a radian. Now, normally, so look at part A. 3 pi over 2 itself is like 270 degrees. But it says negative, which means I need to move negative clockwise 270 degrees. Okay, here's my unit circle. I start at 0. I'm going negative clockwise 270, 90, 180, 270. So negative 3 pi over 2 is the same as negative 270 degrees. 90, 180, 270. So that's at pi over 2, which is 0, 1. Tangent. I don't need to draw a circle. I shouldn't have erased this. Tangent, if you recall, is y over x. So whatever my y value is the numerator. Whatever my x value is the denominator. Here is my x and my y. So that means that I'm going to put my y value, which is 1, over my x value, which is 0. So this is basically tangent of positive 90. Right? Didn't I go to 90 degrees? When I went clockwise, or negative 270, negative 3 pi over 2. If you enter tangent 90 into your calculator, you're going to get an error message because it is undefined. Okay? Then, 675 degrees, I'm going to part B. So the answer to part A is undefined. You get an error message. 375 is 360 all the way around one time, plus another 315 degrees, right? So I'm doing 360 degrees around, plus another 315, right? All the way around. That leaves me at quadrant 3. Oh, I'm sorry. Quadrant 4. It has a reference of 45 degrees, 315 degrees. Okay. So I went around one whole time, and then I went around 315 degrees more. That's how I got 675. So this triangle, I'm sure you can remember, negative red 2 over 2 because I went down, and right, x value is red 2 over 2. Tangent of 675 degrees is y over x. Y over x. Negative 1. I want to go to 9. I'm going to 9. Okay, read number 9 to yourself. It says, what is the cosine of theta if tangent of theta? So they're telling me a tangent, which is y over x, opposite over adjacent. They're also saying, and the theta, the angle measure, is between 3 pi over 2 and 2 pi. What quadrant is that between 3 pi over, look at your unit circle, between 3 pi over 2 and 2 pi? What quadrant is that?
4.
Find 3, what?
4.
4, because it's in between 270 degrees and 360 degrees. Quadrant 4. So I am told that tangent in quadrant 4 is y over x. Negative 7 over 24. I don't know my degree measure. I don't know. My radius is not going to be 1 this time, that's for sure, right? My radius is not going to be 1. What is my radius? I would have to do Pythagorean theorem for this, or I could look at my Pythagorean triples. What's my radius? Seven, 24.
25.
25, thank you. So I was told 2 of the sides. I was told tangent, negative 7 and 24. Now I have to find cosine, adjacent over hypotenuse. Adjacent, 24 over hypotenuse, 25. Right? Okay. Good, good, good. Example 9. On 9, I'm given another one. I'm told that the adjacent over the hypotenuse is negative 15 over 17, and it's in quadrant 2. So I can draw another picture for that. Okay. In quadrant 2, I'm going to draw a triangle. In quadrant 2, I know cosine. So I use the information I'm given to draw a triangle. In quadrant 2, I know cosine. I don't know how big it is, but I know that my triangle obviously hits the x-axis. They always have to. I know adjacent over hypotenuse. adjacent is negative 15. Oh, isn't that, of course? It's going to the left, so it's going to be a negative. That totally is, yes, accurate. Hypotenuse is 17. Good, not 1. My hypotenuse is 17 this time. Find tangent and secant. Secant is the opposite of cosine, which is hypotenuse over adjacent. Secant is hypotenuse over adjacent. Okay, tangent, opposite, oh wait. I don't know, what's this triangle? Oh, I forgot one down here. It's this triangle. It's a Pythagorean triple. 15 something 17. What is it? Something 15 17. In order from least to greatest. Something 17.
8.
8. Good job. 8 high. So, I need this. Tangent, I go back to my angle and I say tangent. Opposite over adjacent. Opposite over adjacent. Opposite over adjacent. 8 over negative 15. Secant, hypotenuse over adjacent. Hypotenuse is 17. Adjacent is negative 15. Okay. Can you please, we'll get that done. I want you guys to try 12 without my help because 12 is review from Friday. So everyone go to number 12 and solve that. Remember, diagonally, the unit has to match up. So the pi sign needs to match up diagonally. Okay, what's 54 degrees? In radians, what is it? Someone. (54) times pi over 180. What'd you get?
3 pi over 10.
3 pi over 10. Very good. Then I did 4 pi over 9. Multiply that by 180 over pi. What'd you get? How many degrees?
$80.
Thank you. Okay. Now, we're going to go back to 11. I got to draw this out. So Kelsey boards one of the outer horses on a carousel. So this is on the outside. The carousel has a 32 feet diameter, which means it has a 16 feet radius, right? You just look at the information and then use, what do I need to know? Well, I need to know the radius. She represents her starting position at the point 16, 0. Ready? She goes around, the carousel rotates 300 degrees and stops. Dun, 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 dun. How many is left for her to go? What angle is this reference angle? She went 300 around. How many is left for her to get to 360? Obviously, yes. Good, all right. 60. Now here's the deal on this. If I have a triangle in quadrant 4, 60 degrees is my reference angle. Obviously, opposite that is going to be the negative rad 3 over 2. Opposite the 30 degrees is 1/2. So when my radius is 1, then she stops at 1/2, comma, negative rad 3 over 2. When my radius is 1, she stops at 1/2, comma, negative rad 3 over 2. If my radius, what's the radius of this path? What's the radius of this carousel? 16. Then multiply the ordered pair, the ending point, the ordered pair, by 16. So 1/2 times 16. Negative rad 3 over 2 times 16. Okay. 1/2 times 16 is 8. This is part A. Negative rad 3 over 2 times 16. Well, this is negative 16 rad 3 over 2. Simplify. Negative 8 rad 3. That's part A. It says, find the coordinates of Kelsey's horse when the right stops. You have to take into account that this path does not have a radius of 1. I can't use my typical ordered pairs. I have to use when 16 is the radius. So here's the answer to part A. We're not doing part B because that involves arcs, and we haven't talked about arcs at all. Your homework is on